Good morning, everyone, and welcome to this session. The name of our session is Demonstrating the Value of Data Sharing to Boost the Agri-Data Economy. I will share my screen now to start this session. Okay, here we go. My name is Giulia Antonucci, and I am business developer at Engineering SPA within the R&D division. And my work is mainly focused on the agri-food sector and the digital transformation for the domain. I'm also co-leader of the task force in agri-food at BDVA. The main objectives of this session are basically the introduction of the potential benefit of establishing a common European data space in agriculture domain, and elaborate on the technological and policy related challenges regarding the use, regarding the data space for agriculture to boost the agri-data economy in Europe, discuss the best practices in the agri-data sharing, and check which are the existing solutions in place, present validated use cases involving data sharing in agriculture, and stimulate the discussion among us. We will have, especially at the end of the session, we will have a real-time survey with some of the main topics discussed during the session. And we will have, in this way, a final set of keywords to enable effective and prosperous agri-data economy. So the agenda is organized in this way. We have 2 hours, and different speakers will give their own view of the topics we will discuss. We will have at the first instance Panos Ilias, which is the task force in agri-food of PTVA leader. And then we will have an overview of a newborn project named Divine, funded under the Cluster 6 in the definition of governance. The data spaces principle and agriculture will be discussed with the help of Silvia Castelli from the International Data Space Association. And again, we will go through the best practices in the domain, the specific domain, starting with Susanna Bonura from Engineering, who will share with us some ideas, some perspective regarding the use of big data analytics and artificial intelligence in the agriculture domain. And then the perspective and some of the results of the large-scale pilot Demeter, thanks to the help of Kevin Dooling from the Walton Institute, and the European farmers' perspective from Daniel Azevedo from Copacogeca. Again, the perspective of the European policies in agriculture, thanks to Szabocs Soltreti, and some best practices on data exploitation from Nikos Kalatsis from New Republic, and finally, the perspective of business modeling and data monetizations with the help of Grigoris Chatsikostas, sorry for the pronunciation, from Footscale Hub. Then we will have the part of the interaction. As I told you before, we will have a real-time survey at the end of the session. So I would say, let's start. I will introduce Panos Ilias. He is an IT business analyst at the Flemish Institute for Agriculture, Fisheries and Food, the ILVO institution. And he also works at ILVO to support the digitalization in agriculture. And he also joined the Copagogiega Agritech Working Group to develop the European Code of Conduct of agricultural data sharing. So please, Panos, go ahead. Thank you.
Yeah, hello to all. Just a moment to share my screen. Yeah, I think it's fine. And thank you, Julia, for the invitation, which will provide me today the opportunity to present the scope, the objectives, the activities, and the short-term priorities of the BDVA task force in agri-food. Yeah, my name is Panos Ilias. I'm a researcher at ILVO, which is a Flemish Institute for Agriculture, Fishery and Food. The last few years, my main research topic has been related to agricultural data sharing, the development of data spaces in agri-food and soil, but also the design and building of platforms like Just Connect. Since the beginning of May 22, a few weeks ago, I'm leading the BDVA task force for agri-food, which is a sector-specific task force, and it's an instrument to develop BDVA activities in the agri-food sector. The scope or the mission of this task force in short is to enable the digital transformation of agriculture, fisheries, aquaculture, and food systems to make them more resilient and sustainable by advising in areas such as big data, AI technologies and services, data platforms, and data spaces. The main objectives of this task force, but also in general of all the task forces in BDVA, is first the development of content for our members, for example, by providing internal reports, but also to contribute coordinated in an organized way to BDVA cross-domain task forces like the European Data Sharing Services Task Force or the Industrial AI, also to generate strategic knowledge for EU policymakers, for DG Agri or DG Connect in our case, and the industry, using publication of positional white papers, but also creating channels to collaborate with sectorial players that maybe are members of BDVA, maybe not. To support the core objectives, we perform as task force some key actions, some key activities. Some of them regularly and some of them ad hoc, depending on the conditions. One core activity is to identify challenges in the agri-food sector, working together, of course, with our members on regular meetings. And the goal is to transform them into opportunities or new initiatives. As an example of a challenge is how can AI and big data or data sharing practices can support carbon farming or climate smart farming. A reverse way, let's say, of working, and probably a more intelligent one, is to identify existing lighthouse projects that deliver content during their implementation or after, and use the content as an input to our task force. And another activity that also support complementarity and aims to build bridges and collaboration with other relevant task forces or working groups is to come closer with organizations dealing with the digitalization of the agri-food sector from different perspectives like GaiaX or IoT. Other initiatives include project creation, organization of workshops on specific thematic, contribution to public consultations like the framework of sustainable food systems, and if needed to participate in BDVA position papers. I would like to stay on the project creation because it's an essential activity, very useful for our members. And as task force, what we have to do is to identify goals existing at different funding frameworks, mainly in Digital Europe and Horizon Europe, and mobilize the community by organizing, for example, brokerage events. As I mentioned, the new leading team of this task force started working a few weeks ago. And within this period, we managed to identify our short-term priorities. The first is to establish links and use our task force to reintroduce our task force to various agri-food stakeholders, and after to connect with existing and upcoming projects, expecting to deliver valuable content to BDVA members. For example, to connect with running projects like Demeter or the Open Day, which both have delivered essential results until now, supporting cultural data sharing or the design of data spaces. But also with new Horizon Europe project like Divine, who deals with the data economy in the field of agriculture and the effects of data sharing and big data, or Governance 18, I cannot say the name yet, which aims to map and improve the data economy for the food system. And of course, with the project coming from the Digital Europe program, like the preparatory action for the data space for agriculture, which is very important project, and the TEFs in the agri-food. Apart from the reverse approach that I presented in the previous slides, we also we're going to work on the direct one, which means we will try to mobilize the community on project development. We have identified and create a list of topics that meet BDVA requirements. For example, topics that aim to explore and mobilize the potential of new technologies and big data and support the resilience of European food systems, which is a hot topic right now, or aim to increase transparency in the markets and data sharing, or can drive to sustainable food system transformation. Another example is stressing AI capabilities for agro-robotics, or identify common standards for interoperability and metadata. As you may see in cluster 6, under the tools destination, most of the identified goals aim to use digital and data technologies key enablers, or aim to innovative governance models that support policies in the agri-food domain. Also in cluster 4, and there we have to, and we would like to work together with the other task forces like the geospatial or the Earth Observation Task Force of BDAVA, because we have a lot of overlaps in some topics. And what is important is that the next few weeks we will, or days, we're planning to organize a brokerage event. So please, our members, join the JAM and use the link that I provide to have access to the identified goal or to contribute further on these goals. The last short-term priority is related to the member engagement and the mobilization or expansion of our community. There is already an open invitation for our members to subscribe themselves using the wiki page in JAM, and for sure, yes, the doors are always open for new BDVA members that want to participate in various activities in our task force, but also in others. What I also like to mention, I think it's important, especially as an active member of BDVA community the last 5 years, I believe it's important to list our principles. So first of all, the minimum activity level. Okay, we will have a minimum activity level, monthly meetings with meaning of meeting published in JAMP to ensure transparency. Second, we foreseen an active role for all our members. So we're not seeking for followers, but for members that wants to participate and collaborate actively. I think this is also what the members wants to do. The third one is to keep a balance between the members. We have to create a good mix with participants that represent different communities, not only research community, but also industrial sector actors, also with different skills, not only about technology, but also about business modeling. And last, the core team that I'm going to present after will be there to do the hard work, to support and facilitate the community. Those conditions will generate trust, I believe, and equal opportunities and effectiveness. And before ending my presentation and leave my place to Joanna, which I believe has more exciting things to say today, I want to introduce Julia. You have, she's organizing the event, but also Francisco. Both of them, they are leading, co-leading the task force. They are very highly motivated and they present two big organizations with experience in various digitalization activities in different sectors, not only in agriculture, and we'll be there for you to support you. Thank you, Julia. I think I was on time and.
Yeah, perfectly on time. Thank you. Thank you very much, Panos, and thank you for sharing with everyone, with our audience and the speakers also, the main activities we are doing and the next steps, which most of them are related to the engagement, to the creation of a community, to go ahead with the real objectives related to the agri-food domain and the use of data for the data economy in agriculture. I strongly support you to join us to build together the next priorities of our task force. Thank you very much. And now, welcome to Joanna Rosaki. She's an electrical and computer engineer at the National Technical University of Athens. She is also lead architect at Demeter. She's doing a really great job, let me say. And she also has a wide experience in research projects. Now she will introduce Divine, which is a newborn project, which aim really to create the infrastructure, let me say, for boosting the data economy in agriculture. So please, the floor is yours.
Thank you very much, Julia, for the introduction. A very nice presentation from Panos earlier on. Can you see my slides on slideshow now, maybe?
Yeah.
Yeah.
Okay, I would like to welcome everybody to this track from my side as well. I'm covered in this slide. I'm the Divine project coordinator that Julia just mentioned. This is a new project that will kick off in October this year. Regarding my background, I am a professor at the National Technical University of Athens, and my research domain focuses around data engineering and the Internet of Things, and specifically in the agri-food domain, and this is why I'm invited here. Divine is a research and innovation action. Its full title is Demonstrating the Value of Data Sharing to Boost the Agri-Data Economy. It has been funded under the recent CL6 call, Gov 120, regarding data economy in the field of agricultural effects of data sharing and big data. It is a 3-year project. Its vision focuses around building an ecosystem that will allow the seamless sharing and analysis of agricultural data. moreover, it aims to evaluate the importance, the significance, as well as the viability and usability of agri-data sharing from various perspectives, including a technical perspective, business perspective, as well as a policy-oriented perspective. To accomplish this, we have planned for a series of pilots. I will say a few words about each of these at the end of the presentation. And eventually via Divine, we aim to give a boost on the agri-data economy that is not mature at this point. We are of medium scale. This project is of medium scale, spans across 8 member states, 8 countries, 15 partners, 4 pilots. However, our potential impact is quite high. We have the potential of reaching, and our target is to reach millions of farmers worldwide via the WFO network. We are linked with 4 ministries of agriculture in Europe, and we have letters of support from all of them. We plan to reach several farmer associations and several EU working groups. So our potential of impact is quite high. Now, this is a very abstract view of the landscape of Divine, of what we are aiming to do in this project. We plan for about 8, if I'm not mistaken, objectives to be tackled. First of all, we need to establish an ecosystem that will aggregate private and public agricultural data and interconnect several existing agri-data spaces, and thus enabling the seamless sharing of data among the interested stakeholders. In order to accomplish this, of course, we need to tackle several technical challenges that are in place. One of these, maybe the most important of these, or at least one of them, quite critical ones, is the data interoperability. So we're focusing also on analyzing and adapting information models in the agriculture sector to enable data interoperability. Moreover, we will be enhancing this ecosystem with facilities that ensure increased transparency of data sharing, data trust, tackle data traceability, data usage monitoring, and so on. As you see on this slide, to enable this, we have established a multi-actor approach that aims to engage farmers from the beginning, from day one, and domain experts, and enable them to co-create our targeted outputs and engage them from at every phase of the system design and development and testing. Moreover, one of our main objectives in Divine is to analyze and adapt agricultural data sharing governance models and policies to enable their usage not only by individual stakeholders, private stakeholders, but also by public and government services, which is a very critical challenge in place that is not addressed at this point. Finally, one of our goals is to adapt the existing data-driven business models that are in place and increase to the extent possible their exploitation by the stakeholders in the agri-food chain. Everything will be demonstrated, as I already mentioned, via series of pilots. So we will be assessing the respective impact, efficiency, and performance of our ecosystem and our developed applications, services, mechanisms, policies, and models. Now, this is an overview of the Divine Agri-Data Value Pipeline. I'm not going to describe this in detail, just highlight the fact that we engage several data sources, as you see on the left, and that there are several places in this diagram, in this overview. We have the engagement of policies and models that will govern the development of our ecosystem. Now, there is a very extended list of stakeholders and targeted groups in Divine that ranges from farmers, advisors, and domain experts to all kinds of industries involved in the agri-food chain, manufacturers, ICT providers, researchers, but also policymakers, owners of digital innovation hubs, emerging industries, the general public, and of course potential investors that may be interested in this domain. We have 5 main expected outcomes. The first one has to do with the support for awareness and informed decisions based on a cost-benefit analysis that will be made available via the project, the increase of transparency data sharing in the entire agri value chain, increase, of course, sharing of agricultural data on private and public domains, contribution to an increased uptake, of course, of digital and data technologies in the agri sector, which has already started, but we're not already there at this point. And finally, to strengthen policymaking and policy monitoring capacities in agriculture and data technologies. There are several technical considerations that we tackle in Divine that range from data modeling, semantic interoperability, already mentioned this, agri-data analytics, fusion knowledge extraction, transparent decision-making, benchmarking, data security, governance models, policy-making, the creation of a stakeholder open collaboration space that will allow for this co-creation that I have aforementioned. And all of these will be integrated the agricultural data space ecosystem that we plan to offer. Our targeted impacts span from scientific, technological to societal and economic. We have 4 pilots planned. First one will take place in Slovenia. There is already an extended infrastructure in place. This will focus on the sector of livestock and sustainable food production, and based on an existing data space, agri-data space in place that will be integrated in our Divine ecosystem. Second one will take place in Ireland and is linked to crop yield prediction model design and evaluation. Third one has to do with, will take place in Greece, and has to do with the new common agricultural policy monitoring, also linked to smart farming. And there is also available a very extended IoT infrastructure in place that will allow the collection, the aggregation of very of high volume data and heterogeneous data of several types. And finally, our last pilot will take place in Spain. It focuses on the organic olive and almond sectors, and will plans to demonstrate the value of agri data sharing on this traditional, let's say, sector of agriculture. This is my last slide. This demonstrates the coverage of our consortium. As I said, we have 8 countries involved in our project: Greece, Italy, Ireland, Germany, Belgium, Spain, Estonia, and Slovenia. We have 6, if I'm not mistaken, research institutes. We have 1 university, we have 3 SMEs, 2 large industries, and 2 public bodies. But as I aforementioned, we're also linked with 4 ministries of agriculture, several farmer associations, and we can access a base of millions of farmers. We're very excited for this project that is expected to start on October this year. Thank you very much for your attention and for participation. Thank you.
Thank you very much, Joanna. Thank you for giving us this overview of this new project. Now is the time for Silvia Castelli from the International Data Space Association. She will go more in depth regarding the principles of data spaces. IDSA is also involved in Divine, and the role is absolutely linked to these principles. Silvia is an industrial engineer, and she is a stakeholder engagement senior consultant at International Data Space Association. And Silvia, the floor is yours.
Thank you for this opportunity and for the presentations. As you mentioned, I will focus my presentation to provide you an overview of how from IDSA and also OpenDI project, we contribute to the design of data spaces and also for data spaces. So my presentation is a message to encourage you to build data spaces, but not build data spaces independently, creating silos, to build data spaces in the same way. So in order to achieve that, we have already experience in shops developed in International Data Space Association. We have identified a list of to-dos for building these data spaces that I will summarize in 6 key points. The first one is the trust. So the trust is based for the spaces. So you need to know who you are going to engage. Also with the identity management for assuring the stakeholders that you are going to engage, and also certification process of the components to see that fulfill the security rules. Second, the security is needed, the authentication, authorization, but also the data usage policies and the policies enforcement are needed in the future data economy, and also the data spaces. Of course, the trustworthy communications, the security by design, when you design the data space, the architecture, and also the technical certification supports to the security. But this trust and security is for the creation of the ecosystem of data. So here we need to make findable, visible. So we need descriptions of data, metadata, brokers to find the data, vocabularies to describe the usage policies and the information model that we are going to share. And we need to make it interoperable in order that we can talk one each other and also between data spaces. And we need to standardize interoperability to make it a semantic interoperability. And of course, this is these all activities is for one purpose, that is adding value. So for creating the data economy. So we need to be able to process the data and generate apps that creates value on the data. And of course, generate data marketplace that could trade the data as an economic asset. That is the main purpose of the data spaces. So what we are doing in international data space is make all these components easier for the participants, for the stakeholders. So what we bring trust into the ecosystem, the data ecosystem, in a way that you can use our reference architecture for designing, or you can use components, security components that we have developed for being used in the projects. But what we are talking, so we are talking about data spaces, and let me explain our understanding about data spaces. So data spaces are the sum of endpoints, and in a way that we have federate endpoints, federate architectures that allows to share data or keep the data where it is generated. Then we can talk about federated machine learning, for example. And what we propose is to generate interoperability between the stakeholders that participate in a data space, but also interoperability between the spaces. So federation and interoperability, creating the silos data platforms or vendor dependency platform. So we promote that owners
Silvia.
The value depends on the services that you provide, not what you have. And of course, make in a trust way on the participants, and also to assure the data sovereignty with your data. For that purpose, playing field where you can based on IDS information model that provides interoperability, but also have the IDSL rulebook that provides a common governance framework for all players to know each other, how to agree. And finally, to contribute to the of the ecosystem, we have developed a certification process to certify the components and also the organizations. And developed the IDS reference architecture model that contribute to this common understanding and interoperability. And how to build data spaces. So in based on IDSA, we propose to build an IDS data spaces, taking in consideration a few minimum components that assures the principles that I presented before, the interoperability, but also the data sovereignty and data usage control. And for that purpose, in an IDSA data space and ecosystem, we have a core components that assure these principles through the IDS connector. The IDS connector allows to share data between the data provider and the data consumer, and you can do what you can do is to share metadata. So with the IDS connector, you can share the data. You don't share the data, you share the metadata with usage policies, and you can publish this metadata on the broker. That is another essential component. And then when you find this data with a certified stakeholder that is guaranteed by the identity provide service, you can find this metadata that you are interested, this data set that you are interested. And then the data is shared between one connector to other connectors. So you don't need to expose the data. And in addition, you have other elements that contribute to the value added, such as the App Store to publish services, or the clearinghouse to assure the traceability. As an example, how to build data spaces, we simplify the process data space in 3 steps. The first is the functional blueprint. It means that you define the technologies, the roles in the data space. Here with the IDS reference architecture model, you can find regarding the security, the rules, how to describe your data space. And then in the second step, you define the business ecosystem, which partners, which business models, use case. And finally, we need to interconnect. And here we have an example from FlexiRobot projects. That FlexiRobot project is for intelligent automation of precision agriculture operationals. It's an innovation actions that builds a platform for flexible, heterogeneous, multi-robot systems for precision farming. And these projects create a platform that it's a data space per se, but at the same time connect this platform with other platforms or other projects. Some of them will be explained later. So when we plan a data space, the ambition should be that this data space in one ecosystem should be interoperable with other platforms and ecosystems. And finally, you already know, in order to build data spaces, OpenDI project has published the design principles to building data spaces. I am going to insist on these design principles because you all already know, and some of them I have explained it before. I just want to make the emphasis that on this on the creation of the data spaces, we realize in writing this position paper that there are some component solutions, some component models or building blocks that contribute at cross-sectorial level to deploy the data spaces. Some of these such as the data models, data formats, the provenance and traceability. Others building blocks contribute to the trust, such as the identity management, access and usage control policies, trusted exchange. Others such as the public data publication, the data market data services, data usage accounting, or metadata protocols contribute to the data valorization, and others contribute to the governance. These building blocks could be technical solution components, but also agreements made between the parties participating on the data space. And apart from in Task Force 1, we want to identify these building blocks that we have already identified on the design principles position paper chapter, but we want to assess these building blocks deep, and for we launch a call for mapping building blocks from projects. Projects such some of them will be explained later. Projects around OpenDI that are being applied. And we want to harmonize blocks, but also services. We want to identify what you already have developed, which are reference implementation, the minimal data spaces to provide visibility and share it. And for this purpose, we will create a building blocks catalog that you can refer when you build your data space to see what is current available. Here, if you are interested to participate, we will publish a call for the survey, for fulfilling a questionnaire. So you can fulfill the survey directly on the website or the publication of this questionnaire. You can organize workshops in your project to contribute to fulfill this survey. And we will organize workshops. The kickoff meeting will be next week. And then we will organize 2 more workshops, one at the end of the month and another one in September, to assess these building blocks and put in common to extract some information and share this information with the community. So here you have an opportunity to contribute to the creation of these building blocks. And that's all from my side, okay?
Thank you very much, Silvia. Thank you for sharing with us the vision and the activity you are doing within the IDSA, and also the kind invitation to follow your activity in the near future. Now,
thank you.
Thank you. Now it's time to discuss the role of big data analytics and artificial intelligence for agriculture. Susanna Bonura is a head of big data in the artificial intelligence unit at engineering at the Research and Innovation Division in the Laboratory of Industry and Security Technology, Research and Innovation. She is a doctor in statistics, and she will go in depth with the use of big data analytics for agriculture. Please, Susanna, go. The floor is yours.
Okay. Good morning, everyone. Thank you, Julia, for inviting me to this important event of Big Data Value Association. I'm Susanna Bonura, and in engineering for several years, I've been involved in coordinating Italian and European research projects with special focus on big data and artificial intelligence. And currently, I'm in particular dealing with how big data and artificial intelligence can give value in the field of smart agriculture. With the wide application of Internet of Things, smart agriculture can count on the exploitation of enormous quantities of constantly evolving data to get effective information through the application of artificial intelligence tools and techniques. But in a data space context, we cannot overlook the fact that farms, for example, are already equipped with their own IT platforms, but probably these platforms don't use machine learning techniques, or if so, they do not have automation mechanisms to update, for example, their degraded machine learning models in their system. So in this case, what to do? In these cases, it becomes crucial to rely on tools that guarantee flexibility and openness. So to make agriculture IT tools work together effortlessly, providing data scientists, data owners, and all stakeholders in smart agriculture context with the freedom of choice to use their preferred or most applicable methods and tools within their platforms. Tools, algorithms, languages, frameworks developed, for example, by third parties. And this capability also represents a capacity to natively support and integrate a community or marketplace, for example, as an extension of a platform. Secondly, it is important to rely on cloud-based solutions that allow fast prototyping of big data analytics applications and then the deployment on premise, if any, by means of a big data analytics as a service approach. In this way, it will be guaranteed reduce complexity, easier scalability, increased flexibility, and last but not least, potential cost savings. And moreover, a key added value could be given by low-code or no-code tools, which make even people who aren't software developers design and test their big data analytics applications. And finally, new challenges in areas like smart agriculture, where digitalization is having the biggest impact, concern the ability to automate tasks such as feature engineering, searching for the best AI model from a set of candidates, the model tuning, the model deployment, and monitoring. Sorry. So, in a nutshell, the message I would like to give you is that a new trend that is rising on the horizon is represented by data science and machine learning platforms. Such platforms support speed and capacity to load data, build and validate models, support enterprise scale ML ops, ML operations, addressing issues like, for example, data volume, parallelism, and the number of concurrent users supported across desktop servers and cloud deployments. In engineering, we have been working on a data science machine learning platform named Alida that can be adopted by all kinds of operators like farmers, business owners, food system operators, agri-tech operators, in general, who is interested to fully exploit big data and artificial intelligence. Alida is a platform, a data science machine learning platform based on advanced frameworks and open source technologies for design, deployment, execution, and monitoring of big data analytics applications. And it is cloud native, so it is able to scale computing and storage resources thanks to an orchestration engine that leverages the capabilities of Kubernetes for the cloud resource management. And in order to facilitate the design of big data analytics applications, Alida also provides an extensible catalog of BDA services that are the building blocks of an application, which covers all stages of the big data management lifecycle, from ingestion to preparation, to the machine learning analysis, to get to the preparation for the visualization. And this catalog can be used both through a web interface and through specific APIs, which will allow the registration of new big data analytics services, the retrieval, and the management in general of such registered services. Alida also provides a web graphical user interface for both streaming and batch design, and the execution, scheduling, and monitoring functionalities can be used both through the web interface and through specific APIs. So, once a workflow has been designed, it generates a whole series of assets around this workflow that can be managed on cloud or deployed on premise, so to be executed and monitoring on premise. And that bundle of these assets, together with the workflow, takes the name of Big Data Analytics application. Alida also provides the features to deploy the whole Big Data Analytics application on premise, or each asset around it, big data analytics services composing the workflow, the trained model, models if any, and the data sets used or generated during the execution of the big data analytics applications. So to conclude, what it is important to notice is that several contexts in the ecosystem of smart agricultures can be improved by exploiting the features of data science and machine learning platforms. For example, for the water resource management, it is just an example where using and combining information from IoT devices, weather stations, satellite imagery, is important to generate more and more accurate recommendation by means of AI tools and techniques for the farmer in terms of irrigation decisions, to save water, reduce costs, and so on. But other examples can be made, for example, animals welfare monitoring, farm management, integrated pest management, and so on. So that's all from my side. I would like to thank you for your attention and participation. Thank you, Giulia. And all.
Thank you very much, Susanna, for giving us this overview of the use of a specific tool for the big data analytics workflow management. Okay, now the next speech will be handled from Kevin Doolin. Kevin is the Executive Director at Walton Institute, and he is responsible for the oversight and strategic direction of the Walton Institute applied and commercial research activities. Kevin is leading a very big project we already mentioned at the beginning of the session, is Demeter. Demeter is a large-scale pilot made of 60 partners and 20 pilots. And we are, let me say, we are building a very interesting experience there. And Kevin will give us an overview of the main best practices they are handling within Demeter. Thank you. Go ahead, Kevin.
Thanks, Julia. Hi, everybody. As Julia said, my name is Kevin Doolin. I'm the Director of the Walton Institute in the Southeast Technological University, which is a newly formed university in Ireland. It was formed on the start of May. Previous to this, we were Waterford Institute of Technology. I just wanted to, and I'm the coordinator of Demeter. I just want to start by talking a bit about what Demeter is itself. As Julia said, we're a large-scale project. We have 60 partners across 18 different countries. And the core goal of Demeter is to implement interoperability across the agri chain from farm to fork, particularly at a data level. And to verify the results of the project, we've planned and are running 20 different pilots across 5 major sectors. And obviously these are already underway. We're midway through the project. We're going to finish in August 2023. We also have very significant dissemination of results, which we hope will result in increased attention on the project and increased uptake on the results, particularly through the involvement of the World Farmers Organization. So the map here just shows very briefly where the pilots are located. But for the purposes of this discussion, I want to focus on what we're doing with data and how it ties into agricultural data spaces. So just to start that off, I want to briefly touch on our technical approach. So what I'm showing on this slide here is the essence of Demeter, which is our Demeter Enabler Hub. And this Enabler Hub provides numerous different types of functionality. First of all, it has the Demeter Dashboard. And the Demeter Dashboard is really the sole entry point into our Demeter ecosystem for Demeter developers and other stakeholders to get access to the technologies. This dashboard makes two interaction spaces available, which we call the stakeholder open collaboration space and the agricultural interoperability space. And it makes these available to human users with Demeter, and I'll describe them in a minute. It also enables Demeter end users like farmers or agronomists or cooperatives and so on to discover what we call Demeter enabled apps and to offer them friendly, user-friendly interfaces so they can access, understand, and control data that's captured or inferred by Demeter. They can perform administrative tasks over their own Demeter accounts, and they can get an overview of the usage of their data by external stakeholders and so on. It's also used by Demeter stakeholders to provide feedback regarding their perceived experience and the added value of the Demeter enabled commodities that they use. So this is really a space where interested developers and stakeholders can register their offered capabilities and resources, and then they act as what we call Demeter providers. On the other side, we've Demeter consumers. These consumers can browse our enabler hub and they can discover different capabilities and resources that might match their criteria for whatever technical problem they're trying to solve. The hub itself verifies all identities and provides support necessary for establishing secure communications amongst consumers and providers. And then the enablers that we make available via the hub, these can either be services that are developed by Demeter or resources that are offered by external stakeholders. So for example, by third-party service providers or platform providers. The hub importantly also connects these resources to the agricultural interoperability space, which supports the provision of team-ups to create relevant combinations of tools and services for farmers, as well as the stakeholder open collaboration space, where we try and support knowledge sharing. This then allows service discovery from a functional and feature point of view to be used during the resolution of challenges that might be set for various technical problems, essentially. And just to mention, critical to all of this is the multi-actor approach, which is quite popular in Europe at the moment, where we support the co-creation of needs, co-generation of solutions, co-shared responsibility for efficient deployments, and co-organization of support for optimal adoption. So essentially, we try and involve all stakeholders throughout all stages of the project. So as you can see on this slide, and you'll have seen it in earlier presentations as well, the agri-tech landscape is very, very crowded at the moment, and always will be. And as a result, achieving real interoperability is a difficult challenge. Some of the key challenges are related to things like the availability of data and multiple different formats that data is provided in, the heterogeneity of data models and semantics used to represent data, and the lack of related standards that dominate this space. And of course, this is being addressed by the Common Agricultural Data Spaces. Our response to this within Demeter is what we call the agricultural information model. And this is a model that has 5 main parts. So we have a core meta model, we've got a cross-domain ontology, we've domain-specific ontologies. We also have pilot-specific ontologies, essentially to facilitate the 20 pilot trials we're running in Demeter, and I'll mention them a little bit later, and a metadata schema to support it. So I just want to show where AIM and so on fits within in our broader architecture of Demeter. So as I said, our architecture is focused around a series of enabling technologies, or Demeter enablers, as we refer to them. And there's 2 types of these. We've got Demeter core enablers. These are mandatory for any interested stakeholder who wants to expose or share its own resources or use the resources that are made available in the Demeter enabler hub. And these provide support for things like communication and networking, semantic and function interoperability, security protection, and they also provide a client interface into the Demeter hub as well. Then we have our Demeter advanced enablers, and these are the more, I suppose, intelligent parts of the system. These are optional and they're discoverable and accessible in the Demeter enabler hub. And here they provide functionalities such as data and knowledge enablers, decision support and performance monitoring, and integrated delivery enablers too. So if we look at our enablers in terms of our reference architecture functional view, and the agricultural information model, it looks as follows. And again, the key to this is the AIM. So the AIM is a common semantic data model which integrates multiple dominant existing models that can capitalize on solutions such as NGS-ILD-based agri-food data model of FIWARE, the Safe for Agri, Adapt Foodie, AgroVoc, and so on models. AIM incorporates and extends these existing technologies and vocabularies that are already available in the agri-food domain. It provides semantic representation of any data or information that's processed and exchanged within Demeter. It's a modular model to which pilot-specific custom ontologies are getting mapped. And all components within the Demeter architecture will then have AIM compliant wrappers. So this morning, actually, we were presenting on the results of our first open call from Demeter, where we had, let's say, external companies coming in, getting some budget from the project and testing out how they can interoperate. And a lot of them have started leveraging AIM and the supports that's provided there. So that was great to see. If anyone's interested in it, that webinar is recorded and you can email me. I can send you a copy when it's available. So just to go a little bit deeper on AIM itself, this diagram shows the various layers of our agricultural information model. And this layered approach facilitates, obviously, interoperability with existing models, alignment with other models by module instead of the entire model, for example, extension of the domain areas that are covered in AIM with additional modules, maintenance and update of the domain model by modifying only specific modules, for example, and mapping to top-level cross-domain ontologies. So there's actually quite a broad range of data types represented within AIM. So things like farm data, like field data, field status, soil data, and so on. Earth observation, like information coming from satellites, remote sensing, imagery, soil maps, and meteorological data like temperature, humidity, wind speed, direction, and so on. Also, we have information coming from agricultural machinery, like engine data, fuel consumption, emissions, and so on. We have representation of data quality metrics. We have field operations data, livestock data, traceability data, for example, for transport, financial farm data, benchmarking data, and KPIs, and farmer information. So very, very broad mix of data, which, as you can imagine, when you start pulling this data down from various different services, you can get a very, very rich contextual overview of any particular farming system. In terms of semantic operability, AIM provides that basis to enable a semantic interoperability data space. So it defines data elements like concepts, properties, and relations relevant to agri applications and includes the semantics associated to the information to be exchanged. So AIM establishes semantic mappings to various standards and ontologies, which I've already mentioned, for example, like FIWARE, ETSI, the EU initiatives like Inspire and Foodie, AgroVoc, OGC, ISO standards, QUDT units ontology, and other dominant solutions like Adapt. In terms of the next steps, the slide here just shows the kind of future plans for AIM. So we want to extend it to include things like traceability aspects, integration with more isobus concepts, interaction with Gaia-X, and so on. We also want to carry on extending AIM with more semantic mappings and technology very specific to our Demeter pilots. And the output of all this work will be available in our deliverable that's coming in October 2022 on the Demeter website. Julia, I see you turn your video on. I have one slide left. Just very briefly, just to touch on some of the pilots that we're running within the project. The purpose of this diverse range of pilots is to verify that these systems work in as many settings as possible. So we have 5 main clusters. We've got water and energy management related to arable crops. So for example, we're looking at smart energy management in irrigated crops or optimal rice irrigation. We've precision farming related to arable crops, so things like in-service, agricultural machinery condition monitoring, or data brokerage and decision support. Under crop health and quality, which deals with the fruit and veg sector, we have things like decision support systems for olive growers. In livestock, for example, we're looking at animal health. We have a dairy farmers dashboard for the milk and meat production chains as well. And then we've kind of got a cross-sectoral set of pilots looking at things like, for example, pollination optimization in apiculture, or enabling transparency in the poultry industry supply chain. all of these are described on the Demeter project website, and please reach out via email or otherwise if you want more details on any of them. And that's me done, Julia. I hope I didn't go too much over time.
No, you are on time. Thank you, Kevin. Thank you very much for your introduction. Obviously, all these resources built within the Demeter project will be resources to be used also for the future, especially for the future of data spaces for agriculture. So I know there are some discussion on that within some partners at Demeter, so I hope we will find a way. Thank you very much, Kevin. So now we will receive some input, some overview from the perspective of the farmers. Here with us we have Daniel Azevedo. He's a director in the commodities and trade team of Copa-Cogeca. I know that most of you already know the organization, but it is a lobby representing almost 70 national farm organizations and cooperatives in Europe. So they worked a lot on the data sovereignty also for the farmers. And Daniel, the floor is yours.
Perfect. Thank you so much for your introduction. Indeed, in European Farmers and Agri Cooperatives, we also established a task force on agriculture technology, and with our aim is to basically enable European farmers and agri cooperatives to actually have access to a wide range of new and safe technologies, including big data, artificial intelligence, IoT, and Earth observation, among others. And this, if you want to know more about Copa-Cogeca, I'll be very happy to answer any of your questions. We represent 22 million farmers and family members across the European Union and 22,000 European agriculture cooperatives. So we are very supportive to the EU common policies. And I think it is important to know the context where we are. The Common Agriculture Policy has enabled the most integrated single market in Europe, and where he has integrated also some measures in terms of investment on precision agriculture, training, and more we will see new technologies to make their way in. Also, the Green Deal brings many commitments, ambitious commitments in terms of sustainability, and we are also suffering already from the impact of climate change, where we need to find measures to support the agriculture production. Of course, the digital single market is very important. We have contributed to the data governance. We are analyzing Data Act and trying to make sure that the agricultural data space will deliver for European farmers. But all these ambitious targets, they mean that they will require continuous investment from European farmers and agri cooperatives. And we see that some of the studies that have come out are showing that it will have severe consequences for EU agriculture, farmers' income, competitiveness, food security, carbon leakage. But we don't see yet big commitments from the European Commission, and in particular to provide the necessary tools to achieve these ambitious targets. And we see the deployment of technologies and access to digital technology and Earth observation, but also, for example, new genomic techniques as one of the tools that will enable us to continue this transition to a sustainable agriculture and at the same time maintain our competitiveness. And what does it mean for us? So digital tools can provide farmers with a large room of maneuver to make good farming decisions. And as was mentioned by the previous speakers, use of artificial intelligence, collection of data, using of remote sensing, bringing in all the data can actually allow farmers to optimize the use of resources at the farm level. It can also enable us to improve the functioning of the food chain. So currently we have very little tools in order to communicate to the consumer the way we farm, how is it done, and some technologies like blockchain or similar technologies can actually enable us to provide more information, but also to have some more data coming from the rest of the chain. Big data analytics or digital markets can also help us to find new markets, whether in the EU or outside the EU. But it is also important that these technologies will deliver also to improve the life conditions of farmers and their families. And the broadband coverage is still an issue that needs to be improved, and is very important to make sure that also the families are comfortable in the rural areas by enabling them to have access to digital services like every urban area has. So we, as European citizens, we should have access to the same services that other citizens have. In terms of simplification and modernization of European policies, digital technologies can also enable us to, provide other services for online applications for different payments, to provide early warnings or advice for farmers in order to implement their commitments, to simplify official control, but with the objective to increase compliance. And we have seen many member states working on how to use, for example, advanced space technologies to enable this to work. And of course, there is a very positive socioeconomic impact when engaging agri-cooperatives. They have a key role in the diffusion of knowledge, on the diffusion of innovation-based approach, new techniques, enabling farmers to access also new technologies, sharing practices, etc. So this is something that we would like to underline. One clear example that we have supported, of course, is, for example, the life guidance, and I think Panos knows this also very well. It is an innovative smart farming solution that aims to reduce the impact of agricultural production and natural resources, using data, using infrastructure that has been established, collecting data from satellites, but also meteorological stations, bringing in the data from the farmers. And this was a large-scale smart farming infrastructure that collected and analyzed data across at least 18 demonstrators in different countries like Greece, Spain, and Portugal, and covering different crops. And they actually obtained very promising results on the use of nitrogen, for example, improving its efficiency, reduction of pesticides use, reduction of water consumption, increase the air quality, and very important for us as well, maintenance or sometimes even improvement in terms of farmer productivity by supporting farmers to choose the best technologies that fit their farm, by providing them advice, helping them with data, and helping him or her to have to do the best farming decisions. And so, from our point of view, there are still some bottlenecks to improve, and we need all the technologies, but we need a policy that will enable us to choose the technologies that we need. And as already discussed by several speakers, there is an issue with infrastructure. We need to improve the connectivity and the interoperability, but also the reliability of access to, for example, to broadband. Digital skills and jobs. We are part of a scheme that has been now putting forward by the European Commission. So we are trying to support as well access to sport decision-making systems. But this is also very important that we have access to good quality data, good data with good quality, an important point is also to improve the trust and the transparency among the food chain. So we have taken a step further in order to come up with a voluntary approach on the principles that you should to share data, recognizing that the right on data produced on the farm or during the farm operations is attributed to the farmer, and maybe used extensively by him or her. So the farmer has the leading role in controlling the access and the use of data from their business. And so we have seen many of these initiatives coming from the European principles in France and in Wallonia, Germany. We've seen in Spain trying to come out also with common principles that could be implemented. At the same time, of course, we are contributing to the definition of the common agricultural data space. We welcome that it was built on the experience of this code of conduct. Some principles that are extremely important for farmers. The principle of consent of the farmer needs to know that how and what data is being collected, digital identity, but also and in context, for example, of the Data Act, it's important that we enable farmers to come together in order to fight contracts that have abusive terms. These are some important principles for us. In terms of data sharing, it will be very difficult to have the data all concentrated in one data space. We believe that the most important is to enable different infrastructure that is already in place, the different platforms to share the data between it, to create a kind of a data highway between, so that the farmer could take advantage of different services that can bring the data from different areas to other areas when he's interested. And of course, as mentioned, improve the interoperability and also portability of data. So there are plenty of initiatives where sometimes we also support. We have worked, for example, partners on the Smart Agri app, so I support the IOF 2020. We have also collaborated with other initiatives, and very often we are participating in new projects, in particular in terms of dissemination and communication. If some of our members are involved, we usually try to support them as well. And for us, this has been a very important area that we are trying to support and to move forward, but always taking the farmer-centric view, and the farmer will always remain at the driving seat. Maybe a farmer will invest a lot on robotics, mechanization, artificial intelligence in his farm, but he will not be replaced. He will have different functions. He will always have the role to control what is happening in his farm, to choose what technologies it needs to deploy to his farm in order to reach his objectives. And of course, farmers have to benefit from the value generated by sharing data. I think that is a principle that we will always keep in mind. And finally, as mentioned, we support these EU objectives to making our union healthier, improving its biodiversity, and producing more sustainable. But we need to have those tools, and that's why we are really encouraging. We are struggling to implement some of these objectives, and we need the support of the European institutions to speed up all the work to provide the agriculture with the tools allowing to achieve those objectives while not reducing our production. I think this is a clear moment, in a moment of war. It is more and more important that the EU agriculture is able to contribute to food security in Europe and in the world. And so we need to have access to these tools, and digital tools are an important part of this package. Smart farming can clearly contribute to the transition to a more sustainable agriculture in taking into account all the three pillars. So I'd like to thank you for this kind of invitation, and I will be very happy to answer any questions that you might have. Thank you very much.
Thank you very much, Daniel, and we really hope the future of the use of digital technology would be more agriculture oriented and more farmer oriented. Okay, so that the point of view that you bring to this table is really important. Thank you very much. And now another point of view, a different angle of discussion would be brought from Szabolcs Soltredi from Farm Europe. He has a master's degree in law and different experience regarding the European policies and the interconnection and interaction between the policies and the socioeconomic, energy and environmental issue in agriculture and forestry. So welcome also to Stapot, and the floor is yours. Thank you.
Good afternoon, everyone. I hope you can all hear me well. I know we're running a bit short on time, so I'll try to be quick and effective. But in case you have any questions, then feel free to put it in the chat or find me later. So as it was said, my name is Demeter, and I work for Farm Europe, which is a think tank on the agri-food sector. Our goal is to analyze different agri-food related policies of the EU and try to propose some amendments to make them better, to make sure that rural businesses can thrive, and to organize a platform and forum for the exchange of ideas. My topic is about data-driven agriculture policies, and I will present these policy perspectives. So just to have a quick jump in, it was said by Kevin as well that there are huge amounts of data sets in agricultural policies already. So just the common agricultural policy has performance and context indicators. The latter has at least 48 different indicators from socio-economic, sectoral, and environmental indicators. So all of these need to be fed with data that has been transmitted from the farmers to the member states and from member states to the Commission itself in order to monitor the different market trends. Moreover, the Commission is trying to make sure that this scope is being enlarged, and now the monitoring will involve environmental and social sustainability as well of farming. The end goal is to make sure that there's real-time data, of course, from the ground to have feedback, and the combination of this whole data can help to make sure to improve our farming policies. Indeed, data is so crucial that based on data, digital agriculture has been named as a founding pillar in the French agriculture for the third revolution in terms of farming. So let's jump into that a bit. As you can see, I brought some pictures just to showcase that farming is not a medieval practice anymore. In fact, more than 70% of tools from agriculture can be linked to digital tools. However, on the other side of the coin, this type of technology is only used by at least a quarter of farms. So we can see that there's a huge potential for a digital expansion and leap forward. Naturally, the question is then, how do we make this possible? How do we ramp up this technological expansion at the right cost for farmers as well? And let's see. So in a nutshell, data has an increasing role from day to day, as there's a huge untapped potential. Speaking of untapped potential, FAO has an initiative called 50 times 2030, which is to solve the problem of data gap in 50 countries of data systems and trying to bridge them. So as we can see on an international level, there's a huge drive to do that as well, not just in the EU, because these data can help to deliver better policies in agriculture as well. The increasing role can be seen on the food chain for all participants, from farmers, consumers, and policymakers, in order to overcome the information gaps and to make sure that we can make better decisions. As it was said already, there's a lot of things on the market available already today, from data collection, analysis, storage, management. The question is, can it be taken up? Of course. And here we can see a difference in terms of speed for different member states as well, and on the farm level. On member states, there are different initiatives as well. For example, France has a 7-step roadmap in order for the digitalization and data to be very well implemented into the member state. Naturally, these are questions which are out of the scope of agriculture. So it touches upon cybersecurity, data sharing, and ownership, which is not usual scope of the agri-food industry. So that adds a bit of a challenge. to being data-driven and to base your decisions on data if you're a farmer. Speaking of the policy perspectives, we can see that agriculture is at the crossroads of transition. So there's the Green Deal, there's the Fit for Digital Age, and the industrial leadership initiatives within the EU. So we can see that there's a lot of demand for agriculture, as it was said by Daniel as well. The Farm to Fork strategy says European agriculture needs to decrease the use of, for example, fertilizers or increase its organic productions. And all of this can only be achieved if we have the relevant data to see if these have indeed have developments. So it is very important to have a link between the Green Deal and the digital Europe to make sure that these can indeed be a reality. Because at the end of the day, what we want is to make sure that from the intentions, we have concrete actions, as it was demonstrated before, and I think by the speakers as well after me, to make sure that there is an emerging agri-data economy that can fully function for the benefit of all the players and EU agriculture and agri-food sector as well. The trend, as you can see, is that there is more and more things going on, which is good because in a way it gets regulated and we have a level playing field. So I'm going to go into some more details on what are these flagship initiatives that we can see on the policy perspective. So some of this has already been touched upon. So I'm just going to briefly say that there's the Common European Agricultural Data Policy that we can see. I put in the details for the procedure, the process, how it will be implemented. The objective of this is, of course, to develop a secure and trusted data space to allow the agricultural sector to share access data transparently to enable the increase in performance. I won't go into further detail on it because you've already listened to a wonderful presentation on this, but I will mention instead the Farm Sustainability Data Network, which is a development from the currently ongoing FADN, which is the Farm Accountancy Data Network. It's basically, which was to monitor the income of business, and now it is being expanded and modernized, which will be used to strengthen and the contribution of policymaking in sustainability. As you can see, the European Commission is currently defining the appropriate tools and methods to collect and provide some of these data. It is actually scheduled for the second quarter of 2022, so just now, and something else which is scheduled even by just now, I mean for tomorrow. It is supposed to be the last trilogue meeting between the Parliament, the Council and the Commission for the regulation on the agricultural input and output statistics, which of course has a big relevance for data. So we shall see what is being cooked in the oven at the moment. Other than this, there are other initiatives and flagship policies like blockchain or the code of conduct that was mentioned before. So I'm not going to dwell into details on this. I'm just going to go to my conclusions, which is to demonstrate, as it was demonstrated, there's a huge challenge and potential for smart farming, for the data-driven agriculture, and for a more digital agriculture. The policy framework is in the construction right now as we speak. So it is important to eliminate the hindering factors such as the cost, the knowledge and expertise issues, standards issues, the lack of infrastructure, and the challenges in managing the data. One of the initiatives of Divine, as it was said by the speakers before, is to address these. So make sure that you keep a track of the project itself, because it will have interesting developments. And at the end of the day, the overall objective is that with the data-driven agriculture, we can overcome food insecurity and provide a sustainably productive, climate-smart food system for all. So with that, I leave you now, and feel free to address me later on or within the chat. And thank you very much for the invitation, and good luck. Thank you very much.
Thank you. Thank you very much for this overview again. So okay, we can say that the way for policy-driven, the data-driven policy is a work in progress. So this is a good news, a good information. And now, before going in depth to the sustainability of everything and what we will have in terms of business models coming from data-driven applications and so on, I would like to introduce Nikos Kalatsis that will give us some details regarding a best practice related to the use of data in agriculture.
Thank you, Julia.
Are you ready? Okay.
Okay. I guess that you can hear me. You can see my slide, right?
Yes.
Okay.
Everything in place. Thank you.
Thank you very much. As Julia just said, my name is Nikos Kalatsis. I'm working for New Republic. I have the role of the head of the technical project management team. And New Republic is a Greek SME company, and since 2015 is heavily involved in smart farming services. I will get into more details on what we are doing in the context of this presentation. So I will try to reduce the time and proceed only with presenting just the core findings of this presentation, given that we are out of time. So I will start with a very short overview of the GESA system. There was a reference to it by Daniel in the speaker before me. And I will mainly focus on the business model that we are following and the future perspectives of the smart farming. And from an application point of view, I mean, we are already experimenting with that. And our future perspectives are in line with the presentations of the two previous speakers, focusing on how we can use the data that are generated in the context of smart farming solutions for additional purposes and more in more detail with the policy monitoring. So I'm not going to get into a lot of details in this, given that you have already registered in this session and you have already attended the previous presentations. You already are aware that agriculture practices are changing. We have now the opportunity of using low-cost but robust technologies and sensors, decision support systems, and data processing is really evolving, and it can assist farmers on optimizing their practices. In the context of the GESA system, we are focusing on advices on three main let's say areas: on optimizing irrigation and pest management and fertilization. And all this is achieved through decision support based on algorithms that are fed by data that are monitoring at the field level. So with regards to the business model that we are following for the GESA system, and given that we started in Greece, and Greece has the characteristic of having many small farms, family farms, which are not large in terms of area that they are covering. The same happens to Cyprus, South Italy. And so there is a problem. There is no capacity for the farmers to invest on technologies that are not sure that they will deliver the results that they like. So what we have done since 2015 is that the GESA system follows a smart farming as a service approach. This means that all the hardware and software equipment and services are developed, deployed, and operated, owned and operated by the service provider. In this case, it's New Republic. So the farmer is registering with this system based on a subscription fee, which is calculated per hectare and per service type that is delivered. The GIS system gets data from various sources, having us, we can categorize them in 4 big categories. The first one is from the field level with weather stations that are adapted to the needs of agriculture. So they are extended with soil moisture sensor and leaf wetness sensors, besides all the typical meteo data gauges. Also, we integrate satellite data and from mainly Sentinel-1, Sentinel-2, and also we get field observations and by experts and analysis that are taking place in labs, like soil analysis and water analysis and things like that. And of course, we have the farm calendar, which is a digital calendar with all the activities that are performed on the farm. All these data, as I said, are processed, centralized in a centralized manner, and the advice is mediated to the advisors in the beginning, which is then, along with the farmer, implemented. So, as I said, it started on 2015. Currently, it's continuously expanding. There are more than 70 projects, let's say, and six different countries. We are continuously developing new models, prediction models for pest infestation and for irrigation. Some key issues here on, that has to do with the business model is that we are not deploying a hardware station in a farm. What we do is that we go in a new area. We are doing an analysis based on historical data, on soil and climate data. So we identify zones that have similar properties, and the hardware installation is installed on places that are represented a bigger area. The idea here is to serve as many possible farms and farmers and cultivations with the same equipment. Here we see the full set or a snapshot of what we are monitoring and in terms of data types. In this presentation now, I'm going to focus more on the cultivation activities, the data that are collected and manually mainly entered by the farmer to the digital farm book, as it's called, or farm calendar. And this is, I mean, let's say the additional utilization of farm calendar data is, let's say, initiated by the changes we have in agricultural policies. So as we saw in the previous presentation, I'm not going to elaborate a lot in this. We have new policies. These policies are having common objectives, and in some cases they are overlapped. For there is a logic behind that. So we have Green Deal, biodiversity, farm fork, and new CAP. All these, they have somehow, in some cases, common indicators, and they all have the same need, that we need additional data sources in order to monitor the indicators and to evaluate whether the policies that are applied have a result or not. Up to now, we have Earth observation services that are assisting, for example, CAP monitoring. What we see from the projects that are currently elaborating on these issues is that Earth observation is not enough. There are problems with small parcels. Satellite images are affected by the weather, and of course, we cannot detect the full set of data that are necessary to monitor the indicators. So there is a need for integrating data from the farm level, from the field level. And we know that there are potential candidate technologies, are geotagged photos, data from machinery and tractors, farmer calendars, and things like that. Now, there is a big problem that, okay, we have these digital agricultural technologies. It's a thriving ecosystem. We can say that it's not anymore research, it's operational, it's commercial. But how can we get this data and how we can, let's say, use them in terms of policy monitoring? And here's a new business opportunity, for example, let's say, for the FMIS, the Farm Management Information Systems providers. We consider that the FMIS can act as a farm level data gateway, which means will be an umbrella technology that will be able to get the data on the farm level, to process them, to store them, to exploit them in order to provide services for the farmer, but to also homogenize them and share this data. So we are experimenting and we are considering that these farm management information systems can operate on a farm level, and besides offering services to the farmer, also acts as the main mean to share this data. In Spain, for the next year, there is already regulations that all farms need to digital record the use of the pesticides and share this data with centralized governmental authorities or regional authorities. So we understand that there is a need for information systems to gather this data and to process them and share them in a controlled manner. It's not something really new, because we see that there are already farm management information systems operating in such a manner for audit process. Audit meaning organic or global GAP, in general for good agricultural practices. So we consider that just to summarize here, that the farm management information systems can extend their operation and work with in-interoperability enablers, an additional wrapper, an approach that was also presented from in the previous session with the IDS connector from Sylvia, and to implement all the access control and interoperability mechanisms that are necessary. Going a step further, and considering that we need to identify correlations between the agricultural data and the data that are generated by the farms that are related with the farm activities, but also with environmental related indicators, we have done some research and we see that there are many ongoing parallel efforts for monitoring similar things. So, for example, for greenhouse gas emissions, we identified that there are some initiatives from JRC, there are some initiatives from other environmental organizations. The same stands for biodiversity indexes. So the way forward, according to our opinion, is that we cannot centralize all these initiatives, but what we can do is to align them and to provide, let's say, the necessary specifications for having interoperable APIs and access control mechanisms in order to create a federated agro-environmental monitoring ecosystem. And in this way, it will be easier to identify hidden, let's say, correlations with, for example, how the pesticide use affects biodiversity in a region. This is something that we are going to experiment and further research and implement mechanisms also in the Divine project. Conclusions, as I said, there are new business opportunities, but a strong research interest on the alignment of these data sources. And the open issues are, as it was previously said, heavily related with interoperability on different levels. I would also like to introduce the issues that we see, because we are in close contact with the farmers, on how reluctant they are, especially because they're afraid of penalties or to be judged for bad practices. Farmers are under heavy pressure currently from different perspectives. So our idea is that we need to avoid establishing an intrusive surveillance infrastructure because simply it's not going to be efficient. It will not work. I mean, after all, nobody knows what a sprayer tag contains. So principles like FAIR and their extensions and the extension of which is CARE is the way forward for us. Thank you very much.
Thank you very much, Nikos, for this. First of all, for the introduction of your experience and your insight. Now we will go within the context of business modeling and data monetization as a conclusion of this session, with the idea to give some ideas regarding a new way, maybe, of the use of data for making business. And we have Gregoris Katsikostas, that is an expert in financing innovation in the agri-tech sector and food tech. From Footscale Hub, Gregoris, the floor is yours.
Thank you very much, Julia. Thank you very much, organizers, for the invitation and for this very interesting workshop. I know I'm the last, so I will try to be fast. I'm Grigoris Katsikostas. I'm Vice President for Business Development at Footscale Hub. Many of you know me from my participation in European projects, but my other passion is supporting the startup entrepreneurship ecosystem in the agtech and food tech domain. I've been in the food soldier in this domain for the past almost 18 to 20 years of my professional life. So I will go quickly now into the three topics that we will cover today. So first, we would like to touch a little bit, what do we need from data? What is that we are looking for when we're looking to create business models that distribute the value across the agri-food value chain? Then we will try to see what are the existing ways that farmers can monetize the data. We will try in principle to summarize and organize a lot of the things that have been said before and put it a little bit more on a business and layman's perspective. And of course, we are aiming here to inspire the technical people in the podium, but also the technical people that are participating in this very interesting event, to think of additional use cases and think where new technologies like blockchain, like remote sensing, like AI can be used in concrete use cases and in concrete business models stemming out of the agricultural practice. And then at the end, I will try to wrap together with you my crystal ball to see what the future will bring and to think how data, business models based on data in the agri-food sector would look like in the future. Let's start as quickly as possible. So, when we're thinking about agriculture in a business as usual scenario, what we're thinking of in pure monetary terms, in pure business terms, we're thinking of high volumes of productions and low margins. This is the fate of our sector. This is how it all starts. Therefore, in a business as usual, maybe 6 months ago or maybe 2 or 3 years ago, before the big disruptions in the food value chain started, I think you all remember that in the initial discussions of this ecosystem about the data-driven agri-food sector, we were asking ourselves, can farmers really earn additional income from their data, and how? Is it monetary income? Is it additional income by improved value that they are putting into their normal services and their production methods? How can farmers earn additional income from their data? In a world where they have to produce a lot and they earn a little in terms of margin for their production. But as I said before, this was in business as usual scenario. It would be very difficult to me to come today to you and present a world where things are going as usual. Unfortunately, this is not the case. We are living now in times where we are facing bottlenecks in logistics, inflation and rising oil prices. We're facing the effects of climate change already, as mentioned before by other speakers, very tough on the agricultural production. And now we're also facing trade restrictions. We know that at least for the near future and the foreseeable future, things are not going to be easy. Things are not going to be as they used to be. Therefore, we see that already we are seeing that we are having lots and lots of problems in terms of our food systems and our food supply chains. We need to rethink a lot of things. We need to rethink how our food system will survive the crisis. We need to rethink the EU food policy implications of the war in Ukraine. We need to think how to avoid the grain shortage and how to avoid the humanitarian crisis that comes along. So the real question that we have to ask ourselves currently with respect to data is, in a world where the food is weaponized, can really data be the shield of European society? Can really data be the shield of the farmers, of the food producers, of the consumers, on everybody involved? Let's see how some things like that can happen. data promise a lot for food systems. Already explained, productivity, sustainability, but also, and very, very important in these days, optimization across global interconnected value chains. And for society, they are offering even more. They are offering resilience. Let's not forget that our food system survived a very big crisis imposed by the COVID. And I think that European farmers performed very well into that. Despite the problems in the labor shortages, despite the restrictions, despite the physical restrictions that COVID imposed. Now we are entering a new phase where we are expecting data to help us in sovereignty, not only data sovereignty or technology sovereignty, but purely in food sovereignty. The ability for Europe to secure food, but also the ability for Europe to help countries that will be in need due to the food shortages. And at the same time, we have the farmers, the most important actor in this game. Daniel explained very well and in detail the concerns of farmers. Let me try to summarize them in layman's words. So the main concerns of farmers are, who has access to my data and for which purpose? Another important question, who makes money out of my data? And why I don't make some if somebody else makes money of the data that I produce? Very valid concern. Can I really keep using my data if I change vendor for my equipment? The data that is collected now is collected through some data collection equipment that most likely is mounted in the farm machinery. Farmers need to know how can they continue using the data if they change vendor, how can they avoid vendor lock-in, which is exactly the opposite of what we see particular from some multinationals in the farm machinery, that they are trying to push things towards the other direction. So that's why the code of contact between the agricultural machinery sector and the farmers is very, very important in the steps forward. And also, the ultimate business question remains, is the cost of collecting data justified by the value? Does it make sense to invest in technologies that is collecting and storing data and to invest in all the other services around it? Will this investment pay back? So these are the questions that our farmers are putting on the table. Let's see now a little bit how farmers are already monetizing their data, or how can they monetize their data in the future. There are 5 simple ways that farmers can reap benefits of aggregating their data. The most common one, and the one that all farmers in Europe, or most farmers in Europe, are currently using, is related to the so-called data verified investment schemes, also known as data for grants. The most common one is common agricultural policy. We know that the common agricultural policy relies on data collection a lot. We have already seen the good potential of satellite data. We already know that satellite data is not enough to collect all the data needed. But the thing is that technologies can bring huge benefits from administrative simplifications. And then these benefits, then this profit can be widespread across the value chain. If I can give you a glimpse in the future, the carbon farming schemes that already are existing in a, I would say, experimental phase, they exist a little bit in the United States, there have been some experiments here in Europe as well, will also be based in data verified incentive schemes. So this remains currently, if we look at pure market terms, this remains the most popular way of farmers monetizing their data by verifying that they are compliant with particular environmental regulations, that they are compliant with the requests of the Common Agricultural Policy regarding greening and so on, and in the future that they would be providing a positive carbon footprint from the production. Another kind of obvious way is the so-called data marketplaces that sell data to third parties. Who are these third parties who would like to buy data of farmers? Traders of inputs, traders of grain, traders of products, insurance brokers, companies that are doing R&D to create new products or services, academia, advocacy groups. There are many, many potential customers. Here, the business model is kind of straightforward. You pay per transactions, and of course, upon consent of the data owner, who is the farmer. So the existing data marketplaces, and I would not mention a specific one because there are many in the market, are competing on the business model that is defining better what do we mean a transaction, namely, do we sell a data set per se? Do we sell the data by volume? Do we sell the data by some methodology that people are bidding for the value of data, and this defines the outcome? There are different ways to do so, but another point where they're competing is the consent mechanism. How do we know that the farmer remains in the driving seat of his data? How do we know that the data creator has still the possibility to make a decision? Another business model of earning money from your data is when you decide to leverage the data for experimentation or demonstration opportunities. This is a niche market, but still growing. The demonstration and experimentation farms that practically you are renting a part of your farm into some company or in some third party for experiments or for demonstrations. You can see some examples here. And in this case, you need to make sure that the data that you are offering to the customer is you have the data infrastructure to collect the data in a proper way so that you can offer this data, because practically the people will be paying for the experiment, but for the result of the experiment. Then, a very interesting business model, and one that fits very well with the European values, is the so-called data cooperatives, the aggregated data selling. We already, an example that many of us know in this room is Just Connect from Flanders. Here, what we're talking about is collective data pools. The benefits here are that they create a critical mass of data that makes sense to be bought, but at the same time, they allow cross-sectoral exchange among stakeholders and value chain optimization. Last way of earning money through data is by increasing the real estate value. The land value, the value of the properties, is a function of the yield of the previous year, the soil conditions, the climatic conditions, the farming practices applied, and so on. So practically, if you want to sell your farm to an investor, to a real estate agent, to a financial institution, you need the data to go along, because the data increase the value of real estate in the same way that the service book increases the value of a second-hand car. Going now to the last part, and I will be very quick of my intervention, what can we expect in the future? What can farmers expect? What business models the future will bring based on the setup and on the circumstances that I explained in the first part of my presentation? So our food system is going under transformation. In the future, we expect that food and energy sovereignty will be in the top of the agenda. Same, it will be the labor shortages and the possibility to overcome them through automation, through use of robotics, through use of automated farming machines. Decentralization and diversification are also core parts of solving the current crisis, solving the current bottleneck. One of the main reasons that we're facing a bottleneck is that the food security of the planet depends on a few crops only. And this is something that we expect to see changing. There is also a problem that these crops are grown in a few places in the world. And this is also expected to change. So both decentralization and diversification are going to be major driving forces of the change that is coming. And also, of course, the systemic change also needs to include the social cohesion factor into the equation. One thing is for sure, while all these things will be happening, the data collection, storage, and processing technologies will reach what we call the plateau of productivity. We will be able to deliver what they promise, and they will be able to deliver what they promise at affordable cost for the farmers. So in the new business models, we can expect that the role of data will be accelerated because the technologies will become cheaper and because there will be many challenges that require the collection of data. But let's think how farmers will make money in the future. Thankfully, they will continue to make money from food production. It's very likely that farmers in the future will also make money from energy co-production, and even in the far future by providing ecosystem services. This means that the investment in collecting, storing, and aggregating data will provide returns, will pay back, but not necessarily in hard cash. One of the biggest mistakes that were in the initial start of this discussion, possibly a few years ago, was this motto, data is the new oil. I hate this for a number of reasons. First of all, because it compares data with a commodity whose business model are based on greed and on exploiting natural resources. Data can be exploited in a way that is based on collaboration across the value chain and preserving the natural resources. It can be the enabler for securing safe and adequate food for our children, for the generations to come, but at the same time, while preserving our European values. We need the data to make sure that the ambitious targets of Farm to Fork and Green Deal will really be materialized. And we need the data to make sure that in this process, we will not leave anyone behind in European society. And for our farmers, for the people who are producing our food and who are also managing a big part of our natural resources, that we can engage them in a fair play relationship with the rest of the society. I hope I didn't take too much of your time, Julia. This was it. Thank you very much. Feel free to contact me in my email or via LinkedIn for further discussion.
Thank you very much, Gregoris, for these insights. Yeah, we are really out of time. I'd like anyway to share with you. You will find in the chat within the Data Week platform, the B2Match, you have a link in which you can answer a survey, some questions regarding the main topics we covered within the session. If I was able to share my screen, I think yes. You can see the first question was, please prioritize the following challenges to be addressed within the agri-food domain. Some of you already answered the question. You need to prioritize these topics. You have no more than 10 minutes. Then we will go to the other question. Let's go to the second question. The voting is closed. Do you envisage any other important food domain challenges apart the ones we discussed? You need to write down some words, some keywords that you think are important for the domain challenges. Maybe you don't have enough time.
No, voting is closed, Julia.
Really? So the voting is closed, but I opened the vote. So you should be able to do that. Probably something went wrong somehow. Nothing. Something appears. Interoperability, other domains, links, and IoT. Please prioritize the next generation agri-food technologies. For now, we have the most voted the artificial intelligence and big data analytics, then the Internet of Things, and advanced space technologies. Do you envisage any other key enabling technologies? Maybe something went wrong with the Mentimeter or with the sharing of Cloud Edge. Do you think the achievement of the main domain challenges introduced in the section, the question 1, can be addressed, boosting the value of agri data? Hopefully, 2 people, hopefully. And yes. Yes, again. So almost hopefully, they can help addressing the challenges. Another question, please prioritize the following data space key elements that you think are most useful to help addressing the challenge. Trustful environment and data sovereignty, data interoperability and portability, need of data quality, emerging and more data-oriented agri-food policies, that the most voted are trustful environment and data sovereignty, need of data quality. We don't have more time. Do you really believe the exploitation of data space in agri-food can push a new wave of innovative business models? You almost agree on yes. Kind of affiliation. Most of you are coming from SME or large company, but I'm quite sure there are, researchers and university. Most of you come from the research centers and some others from SMEs. And few of you coming from the university. Thank you very much. If you find the survey should be still open, you can still answer the questions. I really thank to all the speakers who joined us, who give us this opportunity to share ideas and experiences and inspirations, especially. And thank you to the audience for following us and to stay with us until now. Thank you very much and have a nice day and enjoy at the BDVA Data Week 2022.
Thank you, Julia.
Thank
Bye.
you. Bye.
Bye.
Thank you, bye-bye.
Hello.